Hello everyone, I am Dr. Praneeth and I'll be teaching chemistry today. It will be the part 3 and the last part of the first chapter. I'm excited to connect with you all through the Knowledge Temple platform dedicated to purely quality education and mentorship for the students across India. Here you will be getting a structured learning, live lectures, mock tests and performance based rewards. Okay. So up till now, this will be the last lecture of the first chapter of the chemistry, that is the some basic concepts of chemistry. Okay. Up till now we learned what is the chemistry, what is matter, classification of matter, the properties of matter, the chemical properties, the physical properties. Then we learned about the precision, the accuracy. Then we learned about some significant numbers, how to calculate up to how number, the rules of significant numbers. Then this will be the last step to wind up this chapter, but a very important and crucial thing that should be recollected and that should be reminded. Okay, today we'll be learning about the laws of chemical combination, the atomic and the molecular masses. Okay, so the main objectives of today will be the laws of chemical combination, the Dalton's atomic theory, atomic number and a mass number. Here the Dalton's atomic theory is important short answer question. Okay, so let's get started. So laws of chemical combination is, for example, when there is a particular reaction, A plus B gives C plus D under heating temperature 273 Kelvin. So here we can say there is certain law that should be followed to undergo certain chemical combination. So elements combine together chemically to form compounds. Okay, these chemical combinations are based on some laws. These laws are law of conservation of mass, law of definite proportions, law of material proportion, Gaseous law and Avogadro's number. Okay, as the name suggests, law of conservation of mass. Here mass at reactant site and products are conserved. As the name suggests, mass of A and mass of B are conserved. For example, mass of the reactant is equals to mass of product. Secondly, the law of definite proportions. Here proportion of reactants and products are conserved. Secondly, law of multiple proportions, which we learn in detail in few further time. Okay, now let's learn about law of conservation of mass. It was given by Antonio Lavoisier. This is an important MCQ. Okay, he said that mass can neither be created nor be destroyed, but can only be transferred from one state to another form. Okay, law of definite proportions, or it is also known as law of definite composition. It says that irrespective of the source on a compound always contains same elements combined together in same proportion by mass. For example, copper is 51.35 always, carbon is always 9.74 and oxygen is always 38.91%. Okay, law of multiple proportion states that if two elements combine to form more than one compound, masses of one element that combine with fixed masses of another element are in ratio of small whole numbers. This is thus if there is a reaction taking place of A plus B gives you C plus D. If it is saying that if two elements are combined to form more than one compound, masses of one element, so mass of one element that combine with fixed mass of another element gives rise to a ratio of small whole number, mass of C plus mass of D. So mass of A is equals to mass of B is equals to mass of D plus mass of E. Okay, for example, hydrogen 2 gram and oxygen 16 gram. Here it is in the ratio of 16:32. Okay, the Gaseous law. The Gaseous law of gaseous volume states that it applies only on gases. First of all, this is the primary condition to apply the Gaseous law. Okay, It applies only on gases. It stays at constant temperature and pressure. When gases combine or produce in a chemical reaction, they do so in a simple ratio of by volume. For example, there is reaction takes place in H2 plus O2 gives you H2O. Here we can balance the reaction. Okay, so here you can say the volume is 100 ml, here it is 50 ml, and here 100. So therefore we can say the simple ratio is 2:1 in 2. Okay, now let's learn what is Avogadro's law. Avogadro's law said that the equal volumes of all gases at same temperature and pressure should contain equal number of molecules. It states that the volumes of all the gases at same temperature and pressure should contain equal number of molecules and number. Now let's learn about the Dalton's atomic theory and atomic molecular masses. Dalton's atomic theory states that matter consists of an indivisible atoms. Secondly, it states that the all atoms of a given element have an identical properties including identical masses. Compounds are formed when atoms of different elements combine in fixed ratio. Fourth point is chemical reactions involve reorganization of the atoms. These are neither created nor destroyed in the chemical reaction. Okay. Now what is Dalton's atomic theory? Drawbacks and advantages. The main advantage is its law explains the chemical combination. This is an advantage. The disadvantage is it could not explain the laws of gases, so it is not applied for gas. And it does not provide the reason of combining the atoms. Okay, so this is an important SAQ. Drawbacks and advantages. Okay, so now what is atomic mass? Atomic mass is a very small. Mass of an atom is also called as extremely small. Now how it is measured? Determination of atomic mass. In the 19th century, scientists couldn't determine the mass of one atom relatively, so they tried to measure it on the relative of the another atom. Okay. So determination of atomic mass is basically it is the present system of an atomic mass is based on a mass of exactly 12 atomic mass unit. Standardization is done and masses of all other atoms are given relative to the standard. Okay, so AMU is 1/12 of the mass of the carbon. For example, 1/12 of the mass of the carbon. So that is 1.66056. Let's solve this question. Okay. So here it says that atomic mass of the hydrogen is 1.6736. Calculate atomic mass of the hydrogen in AMU. So what we have to do? We have to just divide it by 1.6. So 1.66056 and here it is given as 1.6736. So it comes across 1.008. Now the denotation of the particular number. Okay, for example, the atomic mass has X is equal to atomic mass number, atomic number, and Z is equal to atomic mass number. Okay, now let's learn what is molecular mass. It is the sum of the atomic masses of the elements present in a molecule. For example, molecular mass of methane. So methane is 1C plus 4 hydrogen. So C we know it is 12, hydrogen it is 1, so is equals to 12 plus 4 is equals to 16. Okay, for example, H2O, 2 into H plus 1O, so 2 into 1 plus 16 is equals to 2 plus 16 comes as 18. Okay, calculate and solve this question. Okay, so here they have given glucose, so 6 into 12 plus 12 into 1 plus 6 into 16. So this comes approximately 72. 12 plus 96. This comes across 180.16. Now let's learn what is the formula mass. Some substances do not contain certain molecules as their constituent. So positive negative entities are arranged in a 3D form. Okay, so this is particularly the lattice arrangement of atom molecules. Okay, So now let's come to the most important part of this lecture, that is the mole concept. Okay, let's learn what is the mole, what is Avogadro's number, what is molar mass, the percentage composition, the empirical and the molecular formula. So why we have to learn mole and what is exactly the mole concept. So atoms and molecules are extremely small in size. Their numbers are in small amount of any substance is very large. To deal with such large number, we invented mole. Mole is just as a number as a 12 dozen has a 12 bananas. A century has 100 runs. That's why similarly the mole has 6.02 10 to the power 23 particles. So the amount of substance that contains as many particles as there are atoms in exactly 12 gram of carbon isotope. For example, mass of one carbon is 1.99 to 10 to the power minus 23. So mass of carbon atom is 12 grams. So 12 divided by 1.99 comes as 6.02 to 10 to the power 23. Okay. Similarly, the entities in moles are the 1 mole of nitrogen gas consists of 6.02 to 10 to the power 23 molecules. Similarly, 1 mole of carbon consists of 6.02 to 10 to the power 23 atoms of carbon. Similarly, 1 mole of ammonia consists of 6.02 to 10 to the power 23 molecules of ammonia. So now let's learn what is the molar mass. Okay, the mass of 1 mole of substances in grams is called as the molar mass. Okay, so the molar mass of water is 18 gram per mole. The molar mass of sodium chloride, that is NaCl, is 58.5. Let's solve this question. Calculate the molar mass of H2O, CO2 and methane. So the molar mass of H2O, it is equals to H equals to 2 into 16. 2 plus 16, that is 18. Here 12 plus 32 gives you 44. Here 12 plus 4 gives you 16. Okay. Let's learn about the percentage composition, the empirical and the molecular formula. Okay. The percentage combination is basically, if you talk about the NaCl, now if there's a question comes at how many percentage of chlorine is present in sodium chloride. So to calculate the percentage combination, there is certain approach to it. The mass percentage of an element is the mass of an element in the compound. For example, if asked about chlorine, so the mass of the chlorine in the compound upon the molar mass of the compound. For example, it is asked in copper sulfate, percentage of copper. So mass of copper is 63.5 as we know. The molar mass of the whole compound is 249, and then you have to multiply by 100. So here it comes as 25.45. Similarly, this question is very important. Calculate the mass percentage of each element in ammonia. Ammonia, we know ammonia is NH3. So ammonia percentage of N in NH3 and ammonia N. So N, we know the molecular mass of N is 14 upon total is 17. H is equals to 3 upon 17. So it approximately comes as 82% ammonia and 17% nitrogen. Okay. So now what is empirical formula? It presents as, is represented as the simplest whole number ratio of various atoms present in a compound. While molecular formula, it shows the exact number of different types of atoms present in molecule or for compound. The molecular formula is equals to N into empirical formula, where N is equals to molar mass upon empirical formula mass. This is a particular tabular method to calculation of the empirical formula. I just want you to just screenshot and just go through it and just let me know if you get anything from this tabular form. So today's summary for today's lecture is the Avogadro's number, then the molar mass, the percentage composition, the empirical formula and the molecular. Most important numericals can be asked from mole concept, molar mass, percentage composition and empirical formula. Okay. The last concept that is to be learned, which should be important from chemistry point of view, is balancing reaction and the stoichiometry and the limiting reagent. Okay. So now learning about the balancing reaction, why we need to balance a reaction. So chemical reaction needs to be balanced so that it follows a law of conservation of mass, which we learned before. How to balance a reaction? This is a quick trick. First, we have to balance any element, then we have to balance the another element without disturbing the balanced previous element. Okay. Thirdly, we have to repeat this step until all elements are balanced. Okay. Stoichiometry. Stoichiometry is the first efficient. Stoichiometry is basically the number prior to the molecule. For example, here the stoichiometry is 2. Here the stoichiometry is 2. So here the stoichiometry ratio is 1:2:1:2. Okay. So this we can say is the stoichiometry ratio. Now let's learn the last concept of today's lecture, that is limiting reagent. Limiting reagent basically is the reactant which gets consumed first. For example, there is a reaction of A plus B gives you C plus D. So now we have to identify if B gets used up first or A gets used up first. To know this, we use the formula to find out the limiting reagent. Okay. For that, we have to first balance the equation, then calculate the moles of each amount, calculate the ratio of the number of moles to that of the stoichiometry. Okay. The question here given is 50 kg of nitrogen and 10 kg of hydrogen are mixed together. Calculate amount of moles. So there they have given us 50 kg of nitrogen. So 50 upon 28 gives you 17. While that of hydrogen they have given us 10 by 22 equals to 4.96. Okay. So they have given the value to So it considers 4.96. So now calculating the moles. For example, 17 they have given by 1 and stoichiometry is 3. So 4.96 divided by 3. So here it comes as 1.6. Here it comes as 1.7. So 1.6 and 1. So this is larger. So therefore this consumes first. So today we learned about the stoichiometry, the balancing of the chemical reaction and methods of determining the limiting reagent. So I hope today's lecture is clear and the first chapter is done. We are almost done with the first chapter. These are some important things that you should be learned. I will be sharing you the PDF of the important notes, the flag charts and the map reading for the last minute revision for your exams. I hope you are good with this lecture and thank you for watching this lecture. If you liked it, you can join us on Knowledge Temple for a complete learning live classes and mentorship, and together let's make learning engaging and rewarding. Thank you.